stand there and actually say some nonsense like water ain't wet?
I love this question because it seems so simple, but there's a whole field of science called surface science that deals with it. And so many others like nanotechnology and nanoscience are dependent on it. And the short answer is no, water is not wet. But stick with me. But Craig, how can you say that? Of course water is wet, it's a liquid. But wetting and wettability are properties of interfaces, specifically interfaces between liquids and solids. Wetting and wettability describe a liquid being able to adhere to a surface and how well it can do so, and it's a measurable quantity. This property, called contact angle, measures the angle between the solid surface and the liquid surface where they meet. And depending on that angle, that determines how wettable a surface is. So on a surface where water will spread out a lot, it has a low contact angle, and that surface is referred to as hydrophilic. And a surface where water just sits there as like a bead of water is referred to as hydrophobic and has a large contact angle. And surfaces that have very large contact angles seem to just completely repel water, and those are called superhydrophobic. And an example of that is a lotus leaf. But yeah, water isn't wet. At the risk of sounding like a madman, not only is water never wet, ice is always wet because of the nature of solids and interfaces. Ice is a crystalline solid, and this means there's a repeating pattern of water molecules. But what happens at the edge of that ice crystal? Normally, if you have a molecule surrounded by other water molecules that are frozen, they're all connected to each other, they're all bonded. But at the edge of that crystal, there's some dangling bonds. There's some of those hydrogen bonds aren't connected to other hydrogen atoms. This means that those water molecules at the very surface of a chunk of ice behave more like a liquid than they do a solid. And they can attract other water molecules like this, and they can essentially create a very thin layer of water on the surface of ice, like a couple atomic layers. And this also makes ice slippery. That thin layer of water can fill in any cracks or defects or like surface roughness and make it essentially a very smooth surface. And that water is like a very low viscosity. So things can kind of just glide right on. And you've experienced this if you've ever stepped outside on a winter day and ate it. And this process is pretty independent of temperature. Even very cold ice can still have that very thin layer of water.